Hello Year 10s, I hope you are working hard at home. For today's science lesson, we're going to be looking at B9, lesson 3, what is anaerobic respiration. So this is continuing on with our biology lessons. We're now on to lesson 3 and we're on page 15. So if you turn to page 15 in your biology booklet, so that's the Year 10 combined B9, we're looking at respiration, and have a go at the do now task. There are 7 questions for you to go through. Pause the video now, have a go at going through them, and then I will show you the answers. So welcome back. We're going to go through the answers now for the do now task. So question 1, looking about why it was doing on the exercise bike inside rather than outside, and said not to include safety reasons. So I've put, thinking it myself, I was like, we can control the temperature of the person exercising. You know, it says at the start the room is 20 degrees. That's why we need to make sure we definitely read the questions. And we've got the same person in the same room doing vigorous exercise, so we can control the temperature of the room, so we're not going to get any side effects there other than they're exercising, and to make sure they're exercising vigorously. If they're outside, when they're going downhill, they could just sit on the bike and take it easy. If they're in the room, we can keep a closer eye on them and make sure they're definitely exercising, and we're controlling that investigation. So question 2, we're looking at where the blood flow did not change. Let's look at that table, and we should have seen it was the brain. Both of them stayed at 750 centimeters cubed per minute. So that's the amount of blood going per minute. It stays the same. Question 3, bit of a maths question. We had to do 22,000, which was the blood flow to the muscles doing vigorous exercise, and when it was resting, it's just 1,200. So we did 22,000, take away 1,200. And we got 20,800 centimeters cubed per minute. Question 4, we're looking at those 2 substances needed in larger amounts, and that's looking back at what do we need for respiration. Hopefully we can remember from our previous lessons we've got glucose and oxygen, or rather oxygen and glucose as I've written there. Either way round is fine. Remembering that our equation for respiration is oxygen plus glucose will make carbon dioxide and water and some energy as well. Question 5, we had to tick a box. So the substances we named in part 4 helped our muscles to respire aerobically. And then question 6, we had to pick 2 substances. I know it's very annoying, it's on 2 pages, so we've had to sort of look both ways. And we'd have got carbon dioxide and lactic acid. So this is where we're starting to look a bit at anaerobic respiration now. The stretch and challenge, which I'm sure you've all done, I really hope you have all done. I am expecting you all to do it. I know you are capable of this. We're looking at ways to increase the blood flow. The example it gives in the question is to pump out a larger volume of blood with each beat. We're going to look at another way we can do that, and it's the heart could pump faster. If it's pumping faster, we're going to get more blood flowing per minute. Hopefully you've done all right with those. If not, go back and have a look at them again, see where maybe you might have gone wrong or maybe made a few mistakes. Otherwise we can get on with the rest of the lesson. So I might hear you saying, if I was with you, but Mr. Lewis, what is anaerobic respiration? I'm going to tell you now, anaerobic respiration is respiration without oxygen. You'd have looked at this a little bit in year 8, so hopefully you can remember it. If not, we're doing it again. So anaerobic respiration is respiration without oxygen. I've told you how I remember that aerobic respiration is respiration with oxygen. So we've got aerobic, it's got that air at the start. Air has oxygen in, therefore aerobic is respiration with oxygen. Anaerobic, we've got that N at the start, so there's no air, therefore there's no oxygen. So anaerobic respiration is respiration without oxygen. And we've got an equation for you to remember. Luckily it's not the balanced symbol one, it's just a word equation. So in animals, we have glucose goes to lactic acid plus energy. If you're doing PE, then hopefully you'll get a bit of a head start on this as well. You sort of go, oh, I know a bit about lactic acid. But actually, we've all probably experienced anaerobic respiration ourselves at some point in our lives. If you've ever done a PE lesson and you've found that your side is really, really hurting halfway through, you go, oh, I've got a stitch, and the PE staff will tell you, no, don't bend over, you need to stand up straight and put your hands behind your head and take deep breaths. And they're right, they're talking about it from a scientifically correct way. They might not know it, but they are. So what has happened to us is we have got a stitch. We've got that pain in our side, and that's caused by the lactic acid. The lactic acid is making our muscles very, very tired. They can't contract properly. Because they can't contract properly, they're not bending, or they're not moving in the right way, and we end up getting a stitch. We often get it in the side because that's muscles that we're not used to using in the right way. When we're running, they are the ones that are working a little bit more. When we become a bit fitter, if you do more exercise, your muscles get more used to doing it, your heart's able to pump properly or better, so we can get oxygen around, so we don't respire anaerobically, we continue respiring aerobically. And you might have noticed that when you're exercising, you're breathing faster, your heart's beating faster, and even when you stop, you continue to have your heart beating fast and be breathing fast. When you've got that stitch, the PE staff's telling you to stand up with your hands behind your head and take deep breaths. That's to try and get enough oxygen back into your body, because we've got what's called an oxygen debt. That lactic acid, we need to turn it back into glucose, because the lactic acid is giving us a stitch. It's also poisonous for us. We need to make sure that we've not got any of it left. So we have an oxygen debt, which is oxygen that we owe back to our body to help convert it back into glucose. So I've got a little bit there just saying what it is. So we need to convert our lactic acid back into glucose. So we need oxygen to do that. So we take deep breaths of oxygen in to repay that oxygen debt, that oxygen that we owe to our body. And that's our oxygen debt. So that is anaerobic respiration in humans. Now, I'm sure I can hear some of you shouting at your screen saying, but Mr. Lewis, what about anaerobic respiration in plants? Don't worry, we're going to come on to that next. And we're going to look at it in yeast as well, because only some plants will do it. We'll come on to which plants will do it at the very end, because that might help you with some of your questions, so make sure you watch all the way through. But yeast is our main one for anaerobic respiration. So again, what is anaerobic respiration? It's that respiration without oxygen. And mainly, yeast is our favourite one to look at. Now, whereas with animals, we had it was glucose goes to lactic acid plus energy, we've got it in yeast, we have a slightly different equation. We have glucose goes to ethanol plus carbon dioxide plus some energy is released to the environment as well. And this comes in very, very handy for us as people, because we can use anaerobic respiration in yeast to give us certain things. So the ethanol that it produces, you might know it as a more common name as alcohol. And we can use that to make beer, wine and various other spirits that have given a lot of people, a job and enjoy drinking. We get that from anaerobic respiration. Take the yeast and we ferment it, we starve it of oxygen, and it produces carbon dioxide, which are the bubbles, and the alcohol. Now we can also use the carbon dioxide side of it. Any of you that enjoy baking will know that you put some yeast in with your dough when you're trying to make bread. And when you do that, you prove it, you cover it up, and it rises, it gets bigger. It does that because the yeast is respiring. It's using some of the sugar that's in the dough already, and it's trying to respire. Because you've covered it up, there's no oxygen in there, so it respires anaerobically, produces carbon dioxide and some ethanol. The carbon dioxide makes those bubbles which allow it to rise, so we get bread that has lots of bubbles in. Now, don't worry, when you're having bread, there's not alcohol in it. That's because when we cook the bread, or we bake the bread, we burn off all of the alcohols. We just get the carbon dioxide. It's also why when you're proving some bread, if you've ever done that before, you'll notice it gets warmer. That's the energy being released. Now, I did say I'd talk about some of the plants. Now, the plants that can respire anaerobically, so some of them do, they grow in places that don't have much oxygen, so such as marshes. So water lilies, for example, grow on the top of ponds. Very, very marshy areas generally. There's not a lot of oxygen around in the water, but they can thrive there, whereas other plants cannot. Okay, so we've been through anaerobic respiration for animals and yeast and some plants. In your booklets, there is a table comparing aerobic and anaerobic respiration. I'm not going to go through that because you are all smart enough to look at it and go, okay, I can see which one is which. I'm not going to bore you with my voice reading that out. What you're going to do for me now, though, is have a go at answering all of the questions. So you'll need to go through them. The numbers are in a little bit of a weird order, I know, but have a go at going through them. I will put the answers up for you later or in our next lesson, so you can go through them and self-mark it. Any problems, please do contact me on Show My Homework or via email. My email address is on the school website, or if you just type in Mr. Lewis in your emails from the school emails, you'll be able to get in touch with me. Otherwise, have a great day. I look forward to seeing you all when you get back. Any problems, again, please do contact me.